Okay, this is my head tracker application that I wrote. I wrote it to basically test out a bunch of stuff. And it connects to the servos, it connects to the sensors in the head, the infrared sensors. And I showed you this big white spot. It's supposed to connect to my video camera, but I had it on the old computer and it slowed the computer down so much because it was only a single core, maybe a two core uh, Atom processor, and it wasn't very quick. But just for grins, I was testing all my programs, and I just happened to hit the connect camera button, and the thing just worked. I didn't have to rewrite anything. So if I do a little pan around the room, there's me. And if I go to the right, the camera goes the other way. But I didn't have to rewrite any of this code at all. But now if I want to take time out from getting Zoe to understand speech, I can work on her getting to understand what she sees in a photograph. What a messy workshop. Okay, here we are again. I got the camera on. You can see it's me. It's a little slow response, but that might be okay. But I can change the tilt on the camera by just moving Zoe's head. And that's me again. Okay, what you're looking at is the BIOS setup screen for my new Geekom computer. It's got an AMI, American Megatrends BIOS in it. And I wanted to show you this setting down here, AC loss control. AC loss control is always on. I set that up like that because what that means is specify what state to go to when power is reapplied after a power failure. And that says always on. So what that means is if the power to the Geekom gets shut off for some reason and then comes back on, it'll start the PC back up. Now, why is that important? There's the Geekom computer, and it's considered a desktop computer, and I'm not running it on its AC power supply. I'm running it off of this DC-DC converter that's been configured to put out 19 volts, which is recommended for the Geekom. But the Geekom would not power up running off of this. It powers up fine when it's running on its AC power supply. And what I think it's doing, I think the AC power supply is sending some kind of a signal over the power wires. It's only two wires, plus and ground, but I think it's sending a power good signal like an old ATX power supply to the PC to turn the PC on. So I had to find a way around that. Now this DC-DC converter is in what they call automotive mode, and it's got an extra wire coming out of it, that yellow wire right there. It's called ignition. And so you can control the power. That's supposed to go to the ignition of your car if you're running your computer in a car. But I'm not. I'm trying to run this thing off of the batteries that go through this DC-DC converter. And
So what I had to do is I changed that BIOS setting, and then I had to do a little rewiring on my AT Mega Arduino. That's why there's all these extra jumper wires in here. I wrote a little program that the power will come on for like 5 seconds and it'll tell that ignition wire, hey, the power's on, for like 5 seconds, and then it turns off for 5 seconds, and then it turns the ignition wire back on again, and because the ignition gets turned off and turned back on, that auto start in the BIOS settings begins to power up the PC. So now I can run the Geekom on batteries or DC power from a power supply like that one, and it will set the voltage up. And what I had to do on this Arduino, besides write a little program, is it was being powered by the USB cable off of the PC, but the problem with that is the PC wasn't powering up, so this board wasn't powering up, so I couldn't use it to turn the PC on. So now I've got it wired directly to the 12 volt DC-DC converter. Like I said, there's two of those. There's the one for the PC, and it puts out 19 volts. And there's the one for all the 12 volt stuff. And so what it does is this board will now power up when the 12 volt supply comes on, and it'll wait 5 seconds, toggle that ignition wire, and then the PC comes up. Here, I'll show you the power up sequence. Right now the power supply is off. This blue LED is off. This Mega is off, no lights on it. Everything's off. I'm going to apply power to the 12 volt DC-DC converter, which will then supply power to the 24 volt or the 19 volt DC-DC converter. That'll give power to the PC. It'll also give the 12 volts power to this AT Mega. The Mega's program is set to pull a pin. Well, it's going to leave a pin high for like 5 seconds. It's going to pull it low for 5 seconds, and then it's going to pull it up high again for the rest of its career. And so I'm going to hit the power supply and we'll see what happens. The blue LED is connected to that ignition signal, so you'll see it come on and then go off and then come on again, and hopefully the PC will come up. Okay, power supply is on. My blue LED was on, and now it's off, and now it's on again. And the PC now has its little indicator lamp right there. I actually put this little mirror-like thing in there that I made so I can see that from outside, from up high. And now this thing's powered up. Now the only problem with this is I can no longer reprogram this AT Mega from my computer the way it's wired now, because when I program it, it loads the program and then it restarts it, and as soon as it restarts it, it's going to pull that ignition wire low and the PC will shut off. So I can't do that. but I can rig it with a manual switch somewhere and have that power applied even when I am programming it. I just haven't done that yet. But this gets around the problem of powering a Geekom computer off of a battery, which is required for Zoe. Well, I've got Zoe taken apart again. Notice there's a big thing missing there that said I/O board on the underneath there. But that is where my 12-volt power distribution board was. And it used to look something like that. And it had a little tie-in for an extra 12 volts, but that was all 4 of those connectors was used for the yellow amber LED marker lights. And they needed to be connected to 12 volts, and then the other wire to those lights goes through my driver board. So that's where this fidget board was attached. Well, when I thought the fidgets weren't going to work, I disconnected everything from them and reconnected the orange amber lights to my driver instead, because they're bigger LEDs. They're 12-volt LEDs, and I had to run into those little red ones. Anyway, this thing was running out of room, and when I added the Geekom PC, I put some fans in there, 2 of them, and they're 12-volt fans to keep it cool, because it's going to be all enclosed in this box, and I wanted to keep the air moving around it. And then when I came up with my solution to starting the PC from power up from this Arduino, I had to put this connection here on there, 12 volts. And I keep adding 12-volt items to this. So what I decided to do is I'm going to rebuild this power distribution section here and remount the fidgets board to a new board that's a little bigger than this. And I'm going to add some more connections, and I'm going to add a couple of more banana jacks. Well, with the old computer, I had a lot of my 12-volt connections on this board here. There was a fidget board and banana jacks to connect into the 12-volt power supply. But since I've added the new computer, I've noticed I have to have more connections to the 12-volt power supply for the new fans, and now the Arduino board that controls the power to the new PC, the 19 volts. And this board that was mounted on there, and that's where the 4 banana jack connections were. But now, since I needed more, I built this board. And as you can see, it's a little bit longer. It's got a little more room here for the a bigger piece for the banana jacks, and this piece here is going to have some additional connections for the 12 volts. And the way this is going to fit into the computer, or I'm sorry, the way it's going to fit into the PC, I'll be able to access it from this secret door with the Arduino on it. So now all I got to do is finish assembling this. All right, the new 12 volt power distribution contraption is assembled. I've got the fidget board mounted on there, and the old one had 4 places for banana jacks, and the new one has 6. Also, on this side, it had a 12 volt connector there, 4 places for wires. That was for the amber marker lights around the outside of the robot. And I added 2 more 5-pin screw connectors. One is 12 volts, the other one is ground. And they all mount together on this board. And that's going to go back into Zoe. The grain on that wood right there, that is a piece of redbud tree that I cut out of my front yard. And this piece of plywood is an old piece I had in the back of my truck for a long time. So, and this is redbud. Okay, here's Zoe. She's all buttoned up, back together with her new 12 volt power distribution board. It's buried underneath all those wires. There's my connectors. There's my fidget board. It's all hooked up. Now I'm going to test it out.
Okay, I got Zoe all put back together and buttoned up, and tested her sensors and her amber marker lights around her body, because around the computer section, because that's where most of my wiring had to do with. So that part's working, and I've got 2 new functions I wanted to show you. Pick a number between 1 and 100.
A number between 1 and 100. I will pick 26.
Pick a number between 1 and 100.
Didn't you just say that? A number between 1 and 100. I will pick 69.
Pick a number between 1 and 100.
I think you just said that. A number between 1 and 100. I will pick 92.
Pick a number between 1 and 4.
A number between 1 and 4. I will pick 1.
Pick a number between 1 and 4.
A number between 1 and 4. I will pick 1.
Pick a number between 1 and 4.
A number between 1 and 4. I will pick 2.
What is the square root of 144?
The square root of 144 is 12.
What is the square root of 49?
The square root of 49 is 7.
What is the square root of 50?
The square root of 50 is 7.07106781186548.
What is the square root of 51?
The square root of 51 is 7.14142842854285.
You're very smart.
Well, I am trying very hard to be a good robot.
Are you staying out of trouble?
Ah. It's funny you should ask me that. Of course I am staying out of trouble.
Who is your favorite human?
I'll have to ponder that for a bit. Tom is my favorite human because he is the one that gives me my upgrades.
Who is your favorite robot?
Now that is the right question. My favorite robot, It's a toss-up between HAL 9000, from the movie 2001, and Robot B9 from the old Lost in Space TV show.
Pick a number between 2 and 3.
A number between 2 and 3. I will pick 2.
Pick a number between 2 and 4.
A number between 2 and 4. I will pick 2.
Pick a number between 2 and 5.
The 3 laws of robotics are number 1, number 2, and number 3.
Pick a number between 2 and 5.
A number between 2 and 5. I will pick 2.
Pick a number between 3 and 5.
A number between 3 and 5. I will pick 4.
Good choice.
I am working hard to learn my tasks.
I'm glad to hear that.
Shiny.
What's that from?
The TV show, Firefly.
Okay, I want to show you the log and we can see how fast she responded to my questions. Okay, this is what I call Zoe's action log. Says that up there. What I asked her to pick a number between 2 and 5. And that was at 10:51. And she detected a complex command called pick a number on the input. So it looks to make sure that the code exists before the code tries to call it. And if it does, she processes it. Here's where she added it to the chat grid. She added the input to the dialog box, the table. And this is where she sent it to the text-to-speech processor. And this was her reply. A number between 2 and 5. And then she thought about it for a minute. She said, I will pick 2. Here's where she replies, I will pick 2. And that's at 10:56. So that took 5 seconds to process.